So in the previous video, we have discussed about the basic na process behavior. And in this video, on the other hand, we will discuss some scheduling na criteria or metrics to judge which CPU scheduling na algorithm would be the best. Okay, so different scheduling na algorithms have different na properties, and the choice of a particular na algorithm may favor one class of process another. Now, depending on a particular na situation or depending on a particular na process, how can we then ensure that we have selected the best algorithm? So there are a lot of criteria or metrics that have been suggested for comparing CPU scheduling na algorithms. And this include the CPU utilization, the throughput, the turnaround time, the waiting time, the response time, and lastly, the fairness. So let us discuss this one by one. So the CPU utilization is the percentage of the time that the CPU is busy. So conceptually, the CPU utilization can range from 0 to 100%, right? So if you notice when you open your Windows Task Manager, and you can see that the percentage of the CPU that it is being used. So for instance, if you are using a lot of applications, so you have your Zoom open, a Google Chrome open, some programming IDEs that are open, and then you have your word processors all at the same time, the tendency is that the CPU na percentage is also high. Okay, so if it reaches like 90%, or you are using a lot of applications, or you are using a particular application that eats a lot of your RAM or CPU, then it is a heavily loaded na system. Okay, so in a real system, it ranges from 40%, which is a lightly loaded na system, to around a 90%. So if we want an effective na scheduling, so we are keeping the CPU busy, right? So how about for the throughput? So the throughput is the number of processes that are completed per unit time. So imagine that there is only one application running, okay, and it can only complete one process. Would that be ideal? Compared to when there are a lot of applications opened and that all of these applications are also running fairly well and efficient. Okay, so one way to measure that CPU scheduling is good is that there are a lot of processes that are completed per unit time. And that means that if the CPU is busy executing process, then the work is being done. Okay, so one way to measure that one measure of work is the number of processes that are completed per unit time, and that is what we call as the throughput. All right. So what about for the turnaround time? So from the point of view of a particular na process, the important criterion would be how long it takes to execute that process. So for example, you have installed a programming na IDE and you are trying to compile a certain program. What would be an ideal? A program that compiles in a short period of time, or a program that compiles in a long period of time. So the interval from the time of submission of a process to the time of completion is the turnaround time. Okay, so yeah, it's one way to measure how long it takes to execute that process. And then another criteria would be the waiting time. So the waiting time is the sum of the periods that are spent waiting in the ready queue. So we have mentioned earlier that in the CPU na scheduling, what the CPU does is to select which na process to be executed first from the ready na processes. So we have a queue that contains all these processes that are ready to execute. So if that process is spending too much time on that ready queue without being executed, then its waiting time will also be longer. Okay, so how can we minimize that? So if the time that it spends in the ready queue is long, then it means that your CPU scheduling is not that efficient, right? Okay. Now, what about for the response time? The response time is a measure particularly for those systems that are interactive and real time. Okay. And because in an interactiveness system, the turnaround time may not be the best criterion, but response time is more important. Why? Often, a process can produce some fairly early and can continue computing your results while the previous results are being output to the user. So thus, another measure is the time of the submission of a request until the first response is produced. So for example, you are already compiling some program and it took again a long time before it produced a result, right? So the response time is very long and is not very ideal, okay? And we don't want that to happen. So lastly, the performance metric that we can also look at is the fairness. And in this, all processes receive a minimum or maximum fair na CPU resources. So what would be the goal of the CPU scheduling? So we want to be able to maximize the CPU utilization, the throughput, and the fairness, and to minimize the turnaround time, the waiting time, and the response time. So why is this the case? Why is it that we want to maximize the CPU utilization, throughput, and fairness? So because we want that the CPU is executing a lot of processes. So if the CPU is working, then if the CPU is working and is busy, and it means that it is doing a lot of work. So we want to maximize the CPU na resource. And if the number of processes, there are a lot of processes that have been completed, then it means that the CPU is busy and it's doing a lot of work. Okay? So if it does a lot of process, then it is ideal that this throughput is maximized. And while not simple and also not objectively, what would be the term? Would not objectively realistic to measure this, but we want that the processes also receive minimum or maximum fair CPU resources. So we don't want that a certain processes will hoard all of that CPU. So we have a lot of processes and we want to give that each of these process will be given or be allocated the resource that it needs. Okay, so what about the turnaround time, waiting time, and response time? Why do we want to minimize it? So from the definition of turnaround time, it is the interval from the time of the submission of a process to the time of its completion. Okay, so we don't want that a certain process will take too long before it completes a process, correct? So assuming you are compiling a program, it is much ideal if it complies in less than 10 seconds than when it compiles in 1 minute, right? So we want that the turnaround time as well as the waiting time are minimized. And also the response time. So we want that we already receive an output as soon as possible. So we want this also minimized, right? So just to review or to summarize, we want to maximize the utilization, the throughput, as well as the fairness, and to minimize the turnaround time, the waiting time, as well as the response time. In reality, there is no scheduler, there is no a specific algorithm that would meet all of these criteria. So which criteria are most important will depend on the types of processes and expectations of the system. So for example, a response time is a key on the desktop, okay, or in any applications. For example, you are gaming or you are on a website that needs to output information as soon as possible, or you are working on an interactive or a 3D graphics, right? We want that you can already see the output ASAP. So assuming nag-edit ka sa Adobe na Photoshop, diba, you want that every time you click or you do a certain process, you already get a response. Okay, and throughput is more important for MapReduce, for example. Okay, so depending on the kind of process that you need, the criteria will also vary. Okay, so what metric is used more? Typically, it's CPU utilization, and it is trivial in synchronous CPU system. So as I mentioned earlier, the fairness is a little difficult to measure, and it is tricky, even the definition is non-trivial. So there is really no objective way for us to measure that. However, the throughput, the turnaround time, the wait time, and the response time, they may not be more important than fairness, but they are more quantitative, or we can track, it is more tractable than fairness, and can usually be computed for a given scenario. Okay, so in the next examples, we will show you how we can compute for these times. Now, these are some examples so you can understand it better. So suppose we have processes A, B, C, and that are submitted at time 0, and we want to know the response time, the waiting time, and turnaround time of process A. So you can see here that we have a Gantt chart of how these processes execute. So we can see that it is concurrent, and there is a process of interleaving happening. So meaning we have process A gets interrupted, then process B takes its turn, then process C takes its turn, and then at some point, process A executes again. Okay, and then process B, then C, etc., until such time that each of these processes have completed their execution. Okay, so now what would be the response time? The response time of A is 0. Okay, because when as you can see, it already executed. So once it already executed, we can already get a certain response. And the waiting time, as we mentioned, is the amount of time that the process spends waiting on the ready queue. So at this point, B and C are executing. So while B and C are executing, A is on the ready queue and is waiting. So we can actually count this number or this amount of time that the A waits. Okay, and we just have to sum it up and we get the waiting time. So what about the turnaround time? Turnaround time is the interval from the time of the submission of a process to the time of the completion. So at this point, A started and it got completed at this point. So that is the turnaround time. Okay, so how about for the process B? So the process B, the response time is after the after some time period that A has executed. So dito mag-uumpisa yung response time ni B. Okay? And then what about for the waiting time? The waiting time again is the amount of time that the process spends waiting in the ready queue. So at this point, A is executing, so B is waiting. And at this point, C and A are executing and B is waiting. So at this point, B has already completed its execution, and that would be the turnaround time. Okay, and what about for the process C? The response time is the time that is the time before A and B has finished its execution for some time, and before the process C has started its execution. So after this part that A and B have executed for some time, then the response time of C, that's the time when the C already started its execution. Now, the waiting time would be the time that C is in the ready queue and A and B are executing. So we are summing up here the time that A and B are executing while C is not, right? And for the turnaround time is the interval from the time of submission of process C to the time that it completed. Okay, so we mentioned here that it was submitted at time 0. Okay, so that's why the turnaround started here. And C already or completed its execution at this point. So that will be the turnaround time of C. Okay, so in the next video, we are going to discuss some more scheduling algorithms.